bolted connection, bearing capacity of bolt. In general, bearing failure of plate is critical. The applied load is acted upon on the bolt in two different directions in two different plates. If we consider the upper plate, in which the bolt gets shifted to the left and the size of the hole increases, whereas in the lower plate it shifts to the right and size of plate increases. Bearing failure of plate is indirectly calculated by the bearing capacity of bolt. Design bearing capacity of bolt VDPB is given as nominal bearing capacity of bolt by gamma MB, where nominal bearing capacity of bolt VNPB is given as 2.5 kb dt into Fu, where Fu is ultimate tensile strength of plate. Since bearing failure of plate is critical, so tensile strength of plate is considered, and whereas D is nominal diameter of bolt and gamma MB is 1.25 for site weld or for shop fabrication, and T is given as minimum of sum of thicknesses in each connected plate experiencing bearing in same direction. For example, if a 12 mm thick plate and a 16 mm thick plate are connected by bolt, then T will be minimum of, in this direction load is applied, in this direction load is applied. When considering this direction it is 12 mm and in this direction it is 16. So T is minimum of 12 and 16, that is 12. Whereas if we consider a 8 mm thick plate and a 6 mm thick plate are connected to a 16 mm thick plate, and in this way load is applied and this direction load is applied, then T will be minimum of, when considering this direction it is 12 mm thick and in these two directions it is 8 plus 6, that is least of 16, 14, that is 14 mm. Whereas in case of counter sunk bolts, that is bolts are not visible outside, they are counter sunk inside, then this will be the counter shank depth, say it is some D. And in case of counter shank bolts, then T is thickness of plate minus half of the counter shank depth, that is D. Let us take, if this is 18 mm thick plate connected to a 16 mm thick plate using counter shank bolts, and the counter shank depth is say 8 mm, then T will be equal to minimum of, in one direction the thickness is 16 mm, whereas in the other direction it is counter shank, so 18 minus half of counter shank depth, that is 8, that is equal to minimum of 16 and 14 mm, so least is 14 mm. So these are the examples to find out the thickness T, whereas KB is given as minimum of E by 3D naught or P by 3D naught minus 0.25, or the ratio FUB by FU or 1, where E is end distance naught is diameter of hole. D naught is given by the code if the nominal diameter is between, then D naught is given as the nominal diameter plus clearance. If the nominal diameter is between 12 to 14 mm, then the clearance is 1 mm. Whereas if the nominal diameter is between 16 to 22 mm, then the clearance is 2 mm. And if the nominal diameter is 24 mm, then the clearance is same 2 mm. Whereas if the nominal diameter is greater than 24 mm, then the clearance is D plus 3 mm. This is specified by IS 800 2007 in table 19 of the code. And FUB is ultimate bearing strength of bolt, whereas FU is ultimate tensile bearing strength of plate, ultimate tensile strength of plate. And the design nominal shear capacity, nominal bearing capacity of bolt, that is VNPB, should be multiplied with factors, that is 0.7 in case of oversize and short slotted holes, and 0.5 in case of long slotted holes.